This is for Year 11 Specialists. We're going to look at question 3 from exercise, I think it was 21F. Okay, so from the point 0, a yacht sails 3 kilometers east and 5 kilometers on a bearing of 60 degrees true, finishing at point A. So describe the vector OA in terms of distance and its bearing. Okay, so what's happening is, starting at a point 0, okay, you're going directly 3 kilometers east. Okay, so meaning you're traveling on a straight line, straight line as in straight horizontal line, 3 kilometers. Okay, and then it travels at a bearing of 60 degrees. So I'm just going to draw like a dotted line here. So 60 degrees means, it's at a true bearing of 60 degrees, meaning it's going somewhere like this. And it's going 5 kilometers. Okay, so that's 5, and until you reach point A. Okay, so the question asks you, what is the bearing of vector? So describe the displacement, giving the distance and the bearing of OA. So OA is the resultant, so I'll just go here. The resultant is over here. Okay, now two things. I want to find the distance, okay, and its bearing. So the distance we can get is just the length of x, okay, which is OA. Now I actually got enough information to work that out, right? I'm missing an angle because essentially it's a cosine rule question. I need to find out what this angle is. Well, I know this is 60, right? Because that's a true bearing of 60. And I know this is 90. I know this is 90. So if I add them together, so I'll just redraw the diagram. If I add it together, I get 90 plus 60, which is 150 degrees. I've got a 3 here, I've got a 5 there. I can work out my x, because it's going to be just a simple cosine rule. So using cosine rule, x would equal square root of 3 squared, 3 squared plus 5 squared, minus 2 times 3 times 5, times the cosine of the angle between, which is 150. Okay, I'm going to work that out. So I'm going to go square root of 3 squared plus 5 squared minus 2 times 3 times 5 cosine of 150. Okay, 7.74. Okay, so that's going to be 7.74. I'm going to call it kilometers. So that's units. Okay, so that's the magnitude of OA. Okay, I'm just using proper notation just to present my final answer, because that's what it is. Now, all I need to do now is get the bearing. Okay, so note the bearing is, if I draw a 90 degree here, that's north. The bearing O to A, that's A, is actually this bearing here. Okay, so in order to do that, I need to find out what that angle is. Okay, so to get that angle, I've got enough information to get that angle, because I know that angle, this probably looks like 90 degrees too much. That angle there, I can work out because I have 3 sides of the triangle. So I got 3, 5, and we just worked out that was 7.7, was it? Let's go back to the 77447. Okay, I need to make sure that I'm using the answer that's not as round as much, okay? Because if you do chem, you'll know that there's a problem with sig figs. I want to find the angle. The angle would be inverse cos of, again, you're going to use the cosine rule, 7.7447 squared plus 3 squared minus 5 squared over 2 times 7.7447 times 3. Okay, work that out. So you're going to go inverse cos 7, actually, because I've got the answer there, I can save myself from typing it. Just drag and drop it. Squared plus 3 squared minus 5 squared over 2 times 7.774. Okay, so it's 2 times that times 3. Okay, times it. So 18.83 degrees. 83 degrees, we're not done. 8324. We're not done because that's not the bearing, right? The bearing would be 90 minus that. Does that make sense? Because you want the bearing from here to here, not just from, not just the angle on the side of the triangle. So the bearing would be 90 degrees minus 18.8324. So 90 minus the answer gives you 76.17. 7 degrees true. Okay, usually you put an extra digit. It's usually 3 digits. So, look, I'm not going to penalise you if you don't do that, but that's going to be, that's going to be your final answer. Okay, so hopefully that explains how you go about doing this question.